Hello everyone. This is Rashid Kibria from Fixed Research, University of Florida. Today I will demonstrate my developed ARC-FSM tool. The main purpose of this tool is to automatically detect a certain security critical bugs during RTL code compilation. This tool basically extracts control FSM from the RTL design and then analyzes it to identify certain security critical bugs. And for identifying those bugs, we have already developed 18 security rules. You can find all the security rules in the document that I have provided for ARC-FSM. So let's get started. I will run this tool. I will be providing all the examples that I demonstrate in the GitLab repo. So you will be able to find all the examples that I run on and all of these stuff. These designs are basically open source IPs. I am basically demonstrating this tool in our EC Linux server. So the first task you have to do is to source this command to load the iVerilog tool that I have already mentioned. It is kind of dependencies, so open source tool dependency on which ARC-FSM basically relies on. And next, I will change the permission for the user interface that I have provided. And then you can run this /UI to open this graphical user interface. So if I hit on it, it will show us a GUI for this tool, and you can do a certain tasks here. So there will be a couple of tools that is a part of a static security rule checker. One is ARC-FSM. The other tools we will be providing one by one. So first, load the tool here, and then our task is to read all the RTL dependency files. These dependency files are basically the macro files. That means the files which actually holds all the parameter or define statements. For SHA-512 design, we do not have any RTL dependency files, so we will leave this field blank. But we have to load the RTL design file here, and we can do this via simply browsing. We can go here and you will find here two folders. One is not secure, another one is secure. I will first try to analyze the non-secure version implementation of SHA-512. And if I click on that, it will add this, and then I will hit the verify control FSM control bus security rules, this button, and it will show us another sub window. Here, two inputs needs to be provided. One is protected state, another one is the untrusted IP input ports. I have already talked about these inputs in the document file, so please go through it. Now, for SHA-512 RTL design, we can consider CTRL underscore done this state as the protected state, because now this state actually tells that the operation for SHA-512 encryption operation is finished. So this state is very important, because if you somehow bypass all the states and just get into this state directly from the reset state, then it will lead to information leakage problems or other sort of security issues. So this state is out protecting, and that's why you can consider it as a protected state. But as I have already mentioned in the document, it is basically depends on the designer's intuition. So designer should set this protected state very critically, because this sort of stuff, it is very hard to detect all these protected state using some automated fashion. Another input is the untrusted IP input ports, and these are the IP input ports that you do not trust. So here, let's say we take our init as the untrusted IP input port for this example, and I will click on the configure ARC-FSM button, and finally I will click on the exit. So it will start running the tool automatically. So after a certain time period, this graphical user interface will be gone. It means that the completion, the tool has already uh, performed its work. So here you will see that a report is being generated. We can also click on the exit button here to close this graphical user interface. So now uh, here the report has been already displayed in the command prompt. This the same report is also generated in text format, and you can find it here, RTL underscore FSRV underscore report.rpt. And here you will see all the violations that has been encountered in this RTL. So you can go through this report and find out why all of these things are happening. If you look in the RTL, it will be clear to you because I have already mentioned where the bugs were inserted. Those bugs were basically inserted to just to demonstrate the efficacy of this tool, that this tool can identify all of those violations. Here is another graphical representation of the state transition graph, which actually shows us certain violation. Here, this red transition means it is problematic, and it is basically coming from the violations of security rule number 7 and 8. So for having distance and fifth metric based analysis, in the state transition graph, you will see this sort of annotated form. This light blue color means the reset state, and this light green color state, it is basically our safe state or secure state or whatever you can call normal state. But if it is colored with different scheme, then it means that the state transition graph is problematic. It has some structural issues. You can to figure out that, you have to go through this report, and there you will see all the details why those are those stuffs and this sort of thing. There are some sort of color coding schemes I have already employed. I will basically mention it later in the document that what color means what sort of state. So yeah, that is all about analyzing this insecure version of SHA-512. We can also see the secure version of the implementation. So I will again do the same thing. I will load the tool, and then I will go inside here, and secure implementation I will do here. But here, just let's assume that we do not have any untrusted IP input ports here. I will click on configure ARC-FSM, and then I will hit on exit. So yeah, it is finished, and we can click on this exit to close this graphical user interface. And here you see no issues have been detected here because all the issues were resolved. So ARC-FSM also shows you the peak memory usage and the runtime. So if you look here, it is taking a very low memory, and also it is very fast. It is just analyzing all the RTL cores and providing you this report within just 2 seconds. For a big SOC, it can be something like a few seconds. Yeah, I can assume that because I have already run it on a SOC, an OpenRISC 1200 CPU based SOC. So it took like around 10 seconds or 20 seconds. It also depends on the system on which you are running this tool. So yeah, it is all about the demo for ARC-FSM. Thanks for hearing.